Welcome to part 6 of the Gloomwood Inventory tutorial. In this part, we're going to be finishing off what we started last time, which was we spawned the items. Now we're going to make it so that the items actually place themselves in the correct locations in the inventory. And we're also going to include covering adding the text for how many items are in that slot. To do that, we need to start off with one thing first, and that is an enumerator that will allow us to say where do we want the text to appear: top right, top left, bottom right, bottom left. Simple as that. So we're just going to make an enumerator for that to start, and then we're going to get into the item placement. So open up our content browser, go into structures. We kind of have everything here. So we're going to right click, look for blueprints, enumeration, and we'll call this e_text location. And inside of it, we're going to add 4 values. We're going to say top right, top left, bottom right, and bottom left. Pretty simple, just the corners. And now we're going to go into our A item, because that's where most of the stuff is going to happen. Because if you remember where we left off last time, we had our setup that calls this right here. Not pass, I just want to print string. This will get what gets called for each item currently that spawns in addition to the event begin play. But for the event begin play, we said if it is valid, meaning it has an owner, so it is attached to an inventory, we don't do anything on the event begin play. So we do it here instead. So if we play, this should get printed, I believe, twice, because we have 2 items in the inventory, or just 1. If we look here at our inventory, we have only 1. Now pre-populated data only has the I block. So that's why we only get 1 hello. If we play again, we get 1. What we're going to do is we are going to add information here after all of this. After we set our static mesh and we set our item data, we're going to use the data to do all the rest. We're going to get rid of this, and we have a few functions to go through. What I think I'm going to do is we're going to create them all, and we'll then set them up one by one. Some of them we won't be touching today because they involve very much the event dispatchers from the next item we're going to make, which will handle all the movement. But we do need one of them because it is used without its kind of information just to set the location initially. So we're going to start with the first category we'll call adjust text. Not a category, a function called adjust text. Then we're going to have another one we'll call modify text quantity. So then we have get text coordinates. And so how this works is this one is going to adapt the information from here and convert the coordinates into world space, or relative space for the item, sorry. Modify text quantity is very simple. It's just going to change the actual text renderer text to be the number that we need. And I just realized we need to change our text location here from our byte to the e_text. And then we're looking for, I think it was location. There we go, e_text location. So change that, and that does it for the text. So let's put this in a category for text. Next we have adjust location. Put a capital there. Location. We have adjust rotation. We have adjust for grab point. We have adjust transform for grid. And finally, adjust transform to duplicate it for world. So what these all do. Adjust location is very simple. When we drop an item into our inventory, we have coordinates. We know it's either in 0, 0, maybe it's in 2, 0, 2, 3, whatever it is. We have coordinates, and we then, based on that information, will be moving the item to adjust to that location. The same is true for rotation, but for rotation, it doesn't just rotate it. Because of how the pivot points work, if we just rotate it, it'll end up negative. So we need to then shift it somewhat. Adjust for grab point, very similar to how the rotation works, or the idea of the rotation is when you grab an item, we're going to detect where it is picked up. It's going to be, do we grab it, for instance, on the specific point where, let's say, if we have an L, are we grabbing it at which coordinate are we grabbing at? That's what this is for. It will then adjust the movements that it takes into consideration that we are trying to move it from those specific coordinates. Then we have adjust transform for grid and adjust transform for world. These two just adjust the kind of scale of the item based on if it is in an inventory or if it's in the world, because obviously there's a difference between the two, because one is relative to a parent and the other one is just in world space, so its transforms aren't the same. Next, we're going to need, we'll actually put all these in a category for transform. So all of these, all 5 of them, can go into here. But now we're going to have all the events related to the event dispatcher, or the event dispatchers, plural. And we're going to start by putting receive as a keyword, and then we're going to say drag enter inventory. I'm going to put these in a category for receive, or maybe event dispatcher is better. So to add a subcategory to this, we want to add a bar. So it looks like this line, and be careful when doing this. If you have a spacebar after or no spacebar, it will consider it 2 different categories, but it may look the same, and sometimes it causes a bit of issues in the display. So make sure you don't put a spacebar and add inventory to it. Then we're going to duplicate this, and we're going to change the drag enter to drag leave, and same category. Then we're going to duplicate well, it doesn't really matter too much now. Now we're going to say drag enter world instead. And so we're going to change this from inventory to world in the category. So like that, duplicate it, and this time it is leave world. Sorry, no, I got these wrong. These are not called drag enter or drag exit. They're called start drag inventory and start drag world, and these are going to be in a category called start instead. So just rename it and drag it into the next one. Then we're going to have a duplicate of these. Instead of start, it's going to be stop, which is the equivalent to drop. I just decided to name these this way, but it is the equivalent of saying drop the item. So this is going to be, instead of start, it's going to be stop category. So just move both of them. Then we're going to have, once again, another one, but this is going to be reset drag inventory, and another one called reset drag world. And so these are going to go in their own category called reset as well, just to keep things organized. And the last one, duplicate again. This will be called receive rotate item inventory. And this is going to be in a category we're going to call actions. And we're going to duplicate this 2 times. The first one we will change to merge. And the second one we will change to consumed. And so consumed is the equivalent of saying deleted. It means it's been completely consumed in a merge, for example. So that is a lot of functions, and now we're going to go through them one by one. So once again, these aren't too important for now. We'll be looking at those in the next part. But I just wanted to have them out of the way now, but we're going to deal with them in the next part. So let's start with I think we'll go first with the adjust transforms first. So I'm just closing all the functions so that we can actually know which one we're looking at. We're going to put all the functions that we need here, just so that we know what we're working through. So the first thing we want to do is we're going to call our drag enter inventory. And you might be saying, but that's a receive. Now, even though it is a receive and it's going to have information in it, so we're just going to make it for this specific function. So it's going to need a few inputs, even though one of them we can't set just yet. So you know what, for now we'll leave it. I don't think we need them anyway, but they're just useful obviously when it's an event dispatcher. What this is going to do, and the reason we have this, even though it is a receive, is what it's going to do is it's going to say, okay, the item just entered the inventory, so we need to rescale it. And so in doing that, it's just going to pretty much call some of these functions, but just tidy it out of here. Next, we're going to have modify text quantity, because we need to change the number because we just received new information about the quantity. So we want to modify it. Then we're going to say adjust location. And obviously new coordinates here, so that means new location. Next, we're going to use our get rotation here from our data. So we're going to use the BPI share just so we're sure it's safe. It knows itself, but I just prefer to do it this way. We could use the one specifically of get share and it will give us, get rotation. And if we use the first one, or the second one, sorry, it's specifically of A items, but I prefer to use the BPI share. I don't know if there's a specific difference here, but they do give the same results normally. And so with this, we're going to set our current rotation. And so what this will pretty much do is it's just going to get the rotation here, the new one that we just got, and just set it here without too much mess. It's just so that the reason we do it this way instead of just going and breaking from here is because if the player or if you decide that, for instance, you want your get rotation to do something different, maybe you want it to always add 10 degrees, as strange as that may sound, then here would be the most likely place you would do that, or in the set rotation. So in our case, if we fetch, it's better to do it here with our function in the event that we want to have something happen to our rotation every time we call it. So that's why we do it this way instead of by getting our data. So with our new rotation, we can now say adjust rotation. And the last thing we want to do is we want to adjust our text, because if there's a new rotation, then maybe our text isn't in the same location anymore. So we need to adjust that as well. So I think the first one we're going to do is we're actually going to start with our drag receive enter. And the reason we want to do that is because then we get to see, test immediately, is our scaling working correctly? It won't be in the right location, but it will be the right size. So double click to open this, should be empty. What this needs actually is adjust transform to grid. It then needs to call adjust rotation. It then needs to call adjust for the grab point. In our case here, the grab point is going to be 0. So I'm going to get to this in a second. And finally, we want to adjust text, which, because it has all of this, I didn't even have some redundant stuff in my code because of this. If we move this around, we don't actually need a lot of this stuff. So if we put this here first, we can immediately call our adjust rotation from here. And we don't need our adjust text anymore or our adjust rotation here, because we now have them within our inventory drag. So we can move this. And there we go. So I added some extra functions for nothing. We just need these 3 and get rotation. So let's go back to our receive here. So we're going to need one piece of information at the very least here, even though we're not going to be using it. We're going to need an input for our grab point. So search for that, call it grab point, sorry, it's not a variable, and search for 2D vector. This is just, once again, wherever you grab the item, it will get as close as it can to the coordinates and it will store it in something here. And so our adjust for grab points needs to know that value. So input grab point. Okay. So let's start with our transform for grid, because that's the part that will actually change the size. So if we are adjusting transform to grid, that means that the item is now on the grid. So what that means is we can say, okay, get our text renderer and say set hidden in game to be false, because now it should be visible because we are adjusting it to be for the grid. Now we could also have this be in the drag enter inventory. That would work fine as well, but this is only pretty much used here for now, so it's just fine. It should work okay. Next, we want to get our default scene root here. And we want to make sure we set its relative rotation to -90 on the Y. So -90 here, -90. And if we just run this, so for now I'll just leave it disconnected so we can see the difference. I'm going to disconnect this for a second just so we can see what it looks like now before we make this change. So right now if we play and we just move over here, we can see that our L block is facing upwards, which isn't what we want. Because no matter how we look at it, this shouldn't be its orientation, whether it's lying down towards here or down this way, it shouldn't be pointing upright. So let's add this rotation and try that again. Now, if we go closer, it is now lined up correctly. It's still not perfect, but at least has the right orientation. So that's a step in the right direction. Next, we're going to need to rescale it. Now, to rescale it, we're going to get our static mesh here, specifically our static mesh. We're going to say set relative scale 3D, like this. And what we're looking for is we're going to get our get class defaults, because I believe we did this in the first or second part. We made our a blueprint just to store information, and that one was called our rules, our game rules, if I remember well. And in it, we specifically had our inventory scale 3D. So we can actually drag this here, and this should, because I believe if we just, can we open this up? Let's just search for it, open the game rules. We set this to 5. And this is from my testing. If your inventory scale is a different scale or something like that, it will change. So let's try here. Let's go like this. And if we now go and play, it should be very different in size. There we go. So now it looks more right as far as size goes. It's pretty much exactly the size of each individual slot here, exactly as we want it. That's exactly what we're looking for. So that's one extra step done. So now we have our scale. Our scale works just fine. So we can close this and let's handle the rotation next. Now for the rotation, I'm not sure if it will actually do anything here, but we will see nonetheless. So here we want to say static mesh, because most of the time we'll be working for information on the static mesh. We won't ever be changing the actor location. We're going to just be adjusting the static mesh. So we're going to say set relative rotation. And here we're going to have to split it. So right click on our new rotation, split, and we want to make sure we only change our Z, and we're going to get our current rotation here. And even if we do this, even if we play this right now, it shouldn't change anything because the rotation is 0 and it's still 0. It's not changing anything. So the next step though is where it actually kind of starts to change, where we start adjusting. So right now we're going to say get shape, and we're looking for our BPI share, get shape. And this alone isn't enough because, as you mentioned before, this is always the default shape. We need to know its rotated shape because its rotated shape is what we're looking at here, what we're trying at least to look at. So we need to rotate it, and we have a rotate 2D array specifically for this. So get our current rotation here and plug it in. And so this will give us our new rotation, or our new rotated shape, sorry. And with it, we are going to get the information of the size. So we're going to say get get span. And with the span, we are going to use it to adjust kind of our relative location based on our rotation. So before we can actually do that, we need to convert this into a vector. So we're going to say make vector. And this we're going to use to get our static mesh. We're going to, I believe it's set relative location. This, plug it into completed, and we need to multiply this value here by a 2D vector here. So let me just line this up. I'm going to right click. I think I can convert to 2D. Let me just say make 2D vector here so that we're sure. Plug this in, and we're going to hide this for now by putting it in a collapsed node. So we'll say get multiply, we'll call this. And we'll deal with that in a second. First, let's do this. So with this, we can't just immediately pass these in as the span for the Y and the Z and the X. And the reason for that is, I believe I explained it in the previous parts, is that X and Y don't work the same way in 2D as they do in 3D. So the first thing we need to do is we actually need to turn the X into the Y. Otherwise it won't work. But that alone isn't enough. We actually need to also multiply it by a negative, because itself alone doesn't work, because X is inverted in 2D compared to 3D, and it is inverted with the Y. So it's a bit complicated, but pretty much we just need to then multiply it, because right now this is just 0 to, let's say, 3, and we need a distance, so that is not enough. So we need something that changes these coordinates into an actual 3D space or 3D distance. So we're going to make a quick macro, because we're going to use this a little bit. So what we need is a new macro, and this is going to be called get unit scaled. And what this does is it gets our defaults again. So get class defaults. Obviously not a items. We are looking for our rules again. There we go, our game rules. And all we need is our 3D grid size this time, which is, if you remember, 20. And we're going to multiply this by our static mesh, our relative 3D scale, which we're going to break. Although, if in most cases, I'm going to believe that your inventory is square, so we can just use the X, it will always be the same as the rest. So we just want our 3D grid, and we just want to pass this out. Just so you're aware what this does, so I can explain it a bit clearly. So in the previous part, we made our 3D grid size. So what this 3D grid is pretty much is right here. We have the example of the I block, and the I block is 1 in length by 4. And so if we look at the size, that is 80 by 20. And so that means that 20 is 1 unit. It's 1 square. So because obviously these are Tetris blocks, it's very easy to say, well, that means 1 grid in 3D space is 20. So that's how the conversion kind of works. And so what we have here is we have our 20, so the size of 1 grid, or not 1 grid, but 1 slot, multiplied by the scale. So that way we have the actual distance. Because if, for instance, we have an item that is, let's say, in our case, scaled by 5, that means that for distance, we're going to have to move it 5 times the actual grid size. So in our case, 100. Because of it, as I mentioned before, in our, I believe, in our enter inventory, our adjust for transform, we set it to 5, the inventory scale. So let's close this and go back to our rotation. So we want to get that macro that we just made, so get units scaled. And we're going to pass it in here, just like this. And that will be enough for our X. We don't need anything else for that. But on the other hand, for the Y, or for our this one at the bottom here, we do need to know one extra thing. And as I mentioned before, the X is inverted, so it's -1. And now we have the Y as well. Now, one last thing we need to do here, if we run this, I believe we will have some issues, or maybe it will work perfectly because it's just an L block. No, so we don't. So even if this works right now, sorry, I'm stupid. Of course it's not going to work, because right now this is 0, 0. So actually, let's just do this instead of trying to explain it half done. Okay, so this right here, this get multiply is very similar to what we did before with our rotations. It's just going to be kind of the same idea, where each rotation has a slight variance on which distances we need to calculate. So we're going to get our current rotation, and we're going to say if it is double equal to 90, then we can select and we're just going to look for the general select here. And we're just going to pass it all the way here, so it will turn it into a 2D vector. We're going to copy this for 180. And we're also going to copy it for -90. So as I mentioned, like before, so let's just say select, and we'll go through them one by one. If it is minus 90, we want to pass out 0, 0, because that means that we don't need to move it. Its rotation should already have adjusted it enough. And so on false, we're going to do another select. We're going to say, okay, is it equal to 180? If it is equal to 180, we just want to move it on the X. We don't want to touch the Y, we just want to move the X. And finally, the last one, if we plug in on false, we're going to say, if it is true to equal to 90, we're going to move it by 1 on each axis. If it isn't though, that means its rotation is 0 and we just want to move it 1 on the Y. So if we compile this now and we play, we should have our cube here now being shifted a bit onto the side so it's in the actual inventory. Because what it hit was 0 and that means we only move it on the Y. And because we inverted the 2, this is, because normally this would be the Y, because that's the shape we have. But because we inverted the Y, we're moving it by 1, being the X here, moving it and shifting it slightly to the side, because if we look at our pivot point, it's there. So it wouldn't work. So we have to adjust it. So that does it for the basic placement. So we need to adjust for grab point. And in our case, our grab point is right here, the kind of, our grab point here from our parameter here. And in our case, if we look at our set graph, we're just going to leave it at 0, 0. Doesn't matter. It's not important. Because technically now we're just going to place it with no adjustments because it doesn't need it. So adjust for grab point is, as I mentioned before, depending on where you pick the item up, we move the item. So we're not just going to say, oh, just multiply it by the size. We need to actually make a slight adjustment because we want to make sure that it is grabbed in the center of the cube. So we want to add 0.5 to it. So we're going to get our grab point here. We are going to say plus 0.5 and 0.5. And then we're going to multiply it by our unit scaled. So plug it in just like this. Move this a bit so it's a bit, gives it a bit more space. Now with this, once again, this isn't correct. We need to invert it, the X and the Y. So we're going to do exactly that. We're going to say break, make 2D vector control drags that they're inverted. There we go. And next, we just take this, we multiply it by -1 on the X, 1 on the Y. It's pretty much the same thing as we did here, except this time we did the unit scaled like this, whereas in the other case we just did it before, because in this case they're already split beforehand, whereas here they're still a 2D vector. But we're still doing the -1, 1 exactly like we did here. So then we want to break this, and we're going to get our static mesh right here. We'll just grab it from here, that's easier. And we're going to add relative location this time. So be very careful when you do use this adjust for grab point, because if it ever gets called on something with a tick or that happens multiple times, it will start moving by itself, and you do not want that. That is not something you're looking for. So there we go. That is all connected. But we have one little thing we want to do before we say this is done, because right now this is good. It will work just fine for our situation, but there is a little issue. And that issue is, if we're dragging an item right now, this will adjust its location the instant we pick it up. So it won't be happening all the time as we drag, just once we drag for the first time, pretty much. But if we want it to actually appear on top of the items, instead of overlapping and having some Z fighting, we need to add our Z offsets. But we can't do it all the time, so we need to make a select. And the select is very simple. We're going to say get attach, we're going to go back here, just say get owner is valid. Plug it in here. If it's true, then we add the Z offset. Otherwise, we put it at delta location. So right now, if I'm actually just realizing this might cause an issue. Yeah, it did. So as you can see, that kind of shifted it off a bit. And so the reason that is, and that's a mistake on my project, because in my case, as you saw previously, we removed kind of this stuff in our set data. Because of that, now we have our adjust rotation happening first. And this is correct, right? It should be adjusting rotation, then adjusting for grab points. But the issue with this is now this is adjusting, so it's setting its relative location. And then even though this is just our first time, meaning it is in, we're just placing it in the inventory, it is still moving it like if we are dragging it, which we don't want. But we can't just say, for instance, there's not an easy solution to just say, oh, well, if it's 0, 0, we don't move it, because you can grab it in 0, 0. So instead, what we're going to have to do is we're just going to have to make something slightly redundant here and just say here, we're just going to adjust the rotation after again. Even though it's overkill, slightly overkill, it's not the end of the world because it only happens on spawn. If we look now, it is just fine. It's working okay. Adjust text is the last one we're going to do. We're actually going to do modify text quantity and modify or get text coordinates first. So we'll start with get modify text quantity because it's by far the easiest. So let's just do that. Modify text quantity. So very simple. Get our quantity right here. And we're then going to say text renderer, set text right here. And all we're going to do is pass in the integer into the text. And if you want to make some little adjustments here, this is the moment to do it. If you want to say there's a maximum of digits or a minimum, then you can do it here. I think the default is just fine for our case because we shouldn't have more than 10. So it should be fine. There we go. So let's remove that. We're done. Get text coordinates is next. So get text coordinates needs two pieces of information. The first one is going to be our shape. So a 2D vector and an array. So shape. And the second one is the position we want. And this is going to be our e_text location. And the first thing we're going to do is we're going to make a local variable here, or 2 to be precise. So 2 local variables, both of them are going to be of type 2D vectors. So select 2D vectors, L_position we'll call this, and L_current we'll call this one. And we're going to start off by getting our position. Make sure you look for the variable here. And we're going to select. And the selection we're going to do is we are going to pretty much set a default for our position here. So pulling L position, plug it in. And you want to put the following as the values. So 9909 for the top left, 99 for the bottom right, and 90 for the bottom left. And so if you have items that are bigger than 9 in coordinates, then you might want to increase this value, but I doubt you'll really have items bigger than 9, given the grid's kind of size. That would be a bit odd. But if you do, make sure you change these. And next we're going to get our shape, and we're going to go through one by one the coordinates, and we're going to see, is this the highest on the left, is this the highest on the right, based on the choice we made, based on our position input. So this is going to be converted to our current here, and our position is going to be our return. So we need that, we need a return, and we're going to say L position, drag it in, pass it out, and we're just going to name this return value. And so the way this works is pretty much the same as when you're trying to determine which actor is closest to you. It works the exact same way. And so what that means is we are just going to check pretty much current relative to position. But we can't just do that directly. We need to actually know which type of coordinates or which target we're looking for. So we're going to get our position again right here, and we're going to switch. which is just the easiest way to pretty much go through the different options. Instead of doing multiple branches, we just do a switch. So we're going to split all of these just to give us a bit of space here. We're going to add a branch, and we're going to copy this pretty much 4 times. And at the end of the branch, we're going to say position is set to current. And once again, so as I said, copy this 4 times and just give it some space, because we are going to need some space to put all our answers here, or our checks. There we go. And we'll just add a reroute for the bottom one as well. There we go. So the conditions are, you need both of these, so drag both current and position in, split them both, because it's the easiest way to get them. We're going to copy them for all of these, because we need all of them. And for the first one, we're going to say, is this inferior on both of these? So the y to the x and x to the y. Sorry, this needs to be inverted, the opposite way. Position needs to be at the bottom. So is x currently inferior to the position x? And the reason we do this is because it is top right. Sorry, no, I've got my things mixed up here, because it's not the same order as I have. Let me just relook at this. Sorry. So we're doing top right, so let me just move these here. These are for top left. For this, we want position to be at the bottom again, and that's going to be the case for most of them. For all of them, sorry. If x is superior to our x position, but our y is inferior, then that means if either of these are true, so or, then that means that the current value is in the higher top right than the current one, so, or the position here. That means that we can now change the position to the current. Now, in the case of top left, in top left, we're going to say if either of them is inferior, then we get to use it again. And this may seem a bit strange because I'm saying top left and we're saying inferior. The reason for that is because the most top left coordinate is 0, 0. So that's the reason, if you're wondering. It's because in 2D vectors, in our 2D shape, 0, 0 is the lowest value, and that is the top left corner. So don't think about this in 3D. Think of this as if it were a 2D graph instead. So if either of these are true, then we can move this as a condition to change the current or the return position, sorry. So bottom left is next, and we're going to once again put the position at the bottom, and bottom right, got that wrong. For bottom right, we want to get our current. Is it superior to our position x? Or this is also superior. So if either of these are true, that means we can say that we want to change it. So or, once again, plug in the condition, there we go. And so finally, for our bottom left, once again, position at the bottom, we're going to say if x is inferior. So just like for our top left, once again, we're doing the left here. So that means it is in a lower value. But we're talking about the bottom. And so bottom means the value goes up in 2D. So that means we want to say, is it superior? So superior to position, or then we agree on the condition and we can change the position. So this will handle changing or determining the coordinates we want to place our text on. And next we need to adjust it. So that is going to be in here. So to adjust the text, we want to get our text renderer first. We're then going to say set relative rotation, because right now, as you probably saw, it is not lined up to be visible in the inventory. So what we need for this is we want to split this. We want to get our current rotation. We are going to put this times -1 on the Z. And for the pitch, we're going to put 90. And so what this will do is it will pretty much rotate it like this so that it appears upwards. So if we just play this right now, play, if we go and look at our text, it should be now facing the right direction. And it's also changed the number to be 2, like our item here. If we check its item data is quantity of 2. So exactly what we want. Next, we're going to need to get our text coordinates. So get text coordinates. And the issue with this is right now we need a shape. So for our shape, we are going to say get shape. First one for BPI share. And once again, we can't use this as is. We need to say rotate to the array. We need to get our current rotation. Plug this in. And then we can pass in the shape here and actually use it. And for our position, we're going to get our text location, plug this in, and we can now get the coordinates. We're going to store this return right here as a local variable. So we'll call this L_text chords. And we're actually going to, reuse our rotated shape here. So we're just going to add a few reroutes. Just here, there we go, move this a bit, and there we go. And so we're going to use this to get our max values again. So look for get span, and this time we are specifically looking for the actual value, so we're going to have to subtract 1 from each of these. So 1 on the X and 1 on the Y, and this is going to then be changed to a local variable we'll call max X, and another one we'll call max Y. So L_max Y. There we go. Add a reroute just so it's a bit more readable. And there we go. We're going to need to modify our text coordinates again. So we're going to grab them here. We're going to put a reroute here. We're going to right click the reroute and say collapse nodes. And we're going to say modify text chords. Let's open it up. And it's pretty much just going to be the same as last time. It's going to be a long series, or 3 of them, of another selection. So let's move it here. Start with select. We're going to, as usual, get our current rotation. Is it double equal to -90? If it is, then we're going to have to change the values and so on and so forth. So let's start with our -90. So get our text coordinates, drag them in, break the value. And if it is -90, we want to make sure that this is clamped on the X. So clamp float between this and, actually, I just realized we're going to need, so just control double click here to reopen adjust text. We're just going to turn these into floats because they'll be much easier to use. So float, change variable type, float, change variable type. And we're just going to plug these in here and change the integer. There we go. And so now within here in our modified text coordinates, we're going to use those to say get our X, max X, as the maximum value right here. There we go. And we're going to reroute this, and then we're going to say make to the vector and just plug them back into their values. I'm pretty sure this one isn't necessary because normally this should never go over X because it can't. And at the same time, it can never go below 0 because it's only based on the shape. But just for safety, I'm going to leave it for now because the other ones do actually make changes. So copy this, the current rotation, the double equal, and the select, and plug them in a bit further. And this time it's going to be for 180. If it is double equal to 180, what we want to do is we want to do a similar thing. We're going to get our text coordinates. We are going to break the text coordinates. And for the Y, we're going to subtract from the Y, or more like we're going to get the total span here. So our max Y here. And from the max Y, we're actually going to remove the current y. And so what this does is it pretty much is in essence a 1 minus node from material. So it just inverts the value. So if for instance our coordinates y were to be let's say 5 out of 7, then it would become 2 pretty much. That's the idea. Then we're going to make 2D vector, and this is just going to be our y and our x. This is going to become our x, and this is going to become our y. So we're going to invert the 2. And this gets plugged into true here for 180. So next we have one last one, and that's going to be our 90 degrees and our 0 degrees. So plug this in here, and there we go. So for our true being 90. If it is 90, so here we're going to have a bit more to do. We're going to get our text coordinates, so get text coords. We're going to say break as usual. And in this case, it's going to be a bit more. We're going to start by doing the same trick we did with the y earlier, but with the x. So put the x at the bottom, get max x here. There we go. And in this case, we do want to make sure that if we clamp, this float. And the reason we want to do it this time is because we are subtracting the max from it. So if it is 0, it can sometimes go below. And we also want to make sure it never goes above, even though that shouldn't happen. And this time, though, is simply going to be set right back to being the x. So make 2D vector, and this is going to go right here. But before we finish it, we still need the y, and the y is going to use the same thing here again. So we're going to right click to convert this to the L max y, plug this in here, and this will go into the y. So just move this a bit. There we go. So this is what it looks like. Just make sure you have everything right here for this is for the 90 degrees. All of this. Let's do it one last time for the 0 degrees, which is going to be right here. We're going to break our text coordinates. We are going to do the same trick with the x right here. But this time we are going to invert them by saying x is equal to y and y is equal to x. So this is going to be for 0 degrees. So once again, this is what you get for 0 degrees. Feel free to pause to make sure you have it right. This is what you have for 90 degrees. Pause if you need a bit of time to make sure you have it right. This is what we have for 180 degrees. And finally, this is what we have for 90 degrees. So with that out of the way, we can double click to open our adjust text again. And with the adjust text, we want to multiply this first by our get class default again. And once again, our rules, search for that. And what we're looking for is we're looking for our 3D grid size. Plug this in here. Say hide unconnected, we only need the grid size. Multiply this by another minus 0.5. And the reason for this is that we can adjust it so that it is centered on the grid point and not in the top left corner, because that's where the pivot point is. Sorry, not the pivot point. That's just how it would be placed because of how the coordinates work. And then we want to subtract this from this. And we then want to break our 2D vector finally so that we can pass it into our vector for our text renderer. So we're going to now say set relative location. And we're going to plug this in here, here. And we're going to say for our x, we have x. For our y, we have y. Let's just line these up a bit better. Move the text renderer and the set relative. And for the last bit, we have our z. And for the z, we're going to say get text renderer, get relative location. And we're just going to keep it at its same relative location. So in our case, we do need to change that. We're going to put it to 20.1, so that it's just above the item that is 20 units thick in relative space. So right now, if we look at our viewport, it should be slightly higher than it was before at 20.1. And if we go and play, we now can look at it, and it should have the 2 at 20. Yeah, so it is above, but for some reason it's not in the exact right spot. Okay, sorry. The reason it's not adjusting correctly, the reason it looks a bit off, is because I completely forgot something. So I just did some testing here, but I think I know why it is. The reason there's an issue is because of this. Because we haven't actually, because I made some changes to this system itself. So just change the text to 10. Leave this as it is, it's fine. Change this to center. Change the text to be text center as well. And we'll change this to be 20. And so this puts it now in the middle, so it should be better now. If we look at it correctly, it appears, yep, right in the middle of where we would want it to be, which is the bottom of the slot. And so just to test that this is working correctly, we can instead create a O block. And if we create an O block, we'll then know in all the different corners if it's working correctly, or we can even do a ring block, which is just a custom one I made. So let's open our utility widget. So right click, right editor utility widget, drag it here. And we're going to say create new item. We're going to make a ring like this. We're going to open our information, say ring block, select the ring here. There we go. And say max quantity, let's say 15. We can then close this, and for some reason it cleared everything out. I'm not sure why. I'm not sure what happened there. Ring block. I'm not sure what's happening right now. I'm gonna have to figure that out and confirm it for the next part. So if we confirm, we should have our new item. For some reason, it's just hiding everything. But if we go to our data assets, we can see if that worked anyway. So it did work. We do have 8 points, so it works just fine. So now we're just going to go and select you for a second, our chest, and we're going to add an item to it. So go into AC inventory, add, and we're going to add a 5-slot item called ring block. And right now the items should automatically have their text appear in the bottom left. So let's see if that works. If we go up to it, it does indeed appear in the bottom left. And if you're wondering why they're overlapping, it's because I completely forgot we haven't done something yet. So let's first test this again. So let's keep going. So right now it was in the bottom left. Let's try putting it in the top right. If we play, the eye will have it at the top, and this will be at the top right. If we now move it to the top left instead, they should both be overlapping now with the text as well. Yep, we have the 5 and the 2 at the same spot. Let's try bottom right, and then we'll have tested all the configurations. Yep, let's try it here, and oh, that doesn't look good. That doesn't look good at all. Okay. So the issue is, and so the issue is here, right? We're going for the bottom right, which is 9 and 9 on the X and the Y. And so at no point is this ever going above that. The reason is because I messed it up. As I mentioned, as I quickly mentioned earlier, my enumerator isn't the same. It's not top right, top left. It is a different order. So I actually got these wrong. So make sure your top left is 9 on both. And your top right is 0 on the X and 9 on the Y. Your bottom left should be 9 on both. Whereas your bottom right should be 9 only on the X and 0 on the Y. And so if we try this again, it should work correctly. Yeah, so now it's appearing in the bottom right as it should. If we try the other ones again, just to be sure, let's go for the top right, play. And so top right is working fine as well. Let's try top left. Also fine. And finally, bottom left is the last one to test. It is also working correctly. There we go. So now let's make it so that those items don't overlap. And that's the last thing we need, which is the adjust location right here, which is, I believe, the simplest one of them all. Yeah, it's rather simple. So all we have to do is get our coordinates from our BPI share or this item itself. We want to say set actor location, because all we've done before is adjusting the specific, we've been adjusting based on where we've grabbed the item, how it's rotated because of the rotation turning around the pivot point. But now we're actually saying, oh, well, the coordinates are here. This is where the item should be. So to do that, we just move the actor as a whole. And this is obviously relative because the actor is attached, if we remember correctly, to our widget. So we want to get our unit scaled because we need to move it by depending on what we're attached to. So we're going to then say times. We're going to plug in a float. We are going to add -1 on the x, or multiply by -1 and -1 on the x and the y. Split this, split our new location, and plug this on the x, the x into the y, and the y into the z. And you're probably wondering why. That's simply because the conversion for the x would be moving forward. It would be pushing the item forward in the inventory and not up or down, which we up or to the side. So we specifically want the side and up or down, not forwards. So this is how we want to do it. If we now compile and play, we should have the items move to the side. They're no longer connected to each other, and we can even add a third one here just so we can test if our inventory is actually sorting the items correctly. So let's go and say, let's add a T block. Put 3, play it again, and normally it should have moved to the side. Yep, so this is the next valid location it would have found for it, and it works just fine. If we now try and add an L, it might just slot in the coordinates right next to the T block, I believe. If we add L block here. And you know what, we'll add a set, no, we can't add an I, or we can if we put 10 in. Then it should be next to it, yeah. So as you see, it takes up the little hole to the side there because it knows they can fit in that tiny little slot there. So it works just fine. So that does it for all the placements in the inventory. And this, for your information, will also cover technically when we drag and drop items. Because when we drop an item, we're going to call the same thing, adjust location, adjust rotation, adjust for the grab point, and that's all. And it's going to place it just like it did here. So if this is working, technically, once we do the movement, it should also work just fine as well. Thank you for watching. As I mentioned in the previous part, going forward now, when an episode comes out, you can get the project files commented on Patreon if you would like. The next part, we're going to be covering movement, as I mentioned before, and it will be the before last part. It will be the last part technically, and then we're just going to have a bonus part where we're going to add a kind of storefront where you have to pay for items to be able to actually move them off the inventory. So I hope you look forward to that. Thank you everybody again who's been supporting me on Patreon. I will see you guys all in the next part. Thank you for watching. Goodbye.